Hey everyone, we're going to continue with the notes on straight line motion, and in your manual we are on page 97, and once you finish this video I'm going to ask that you do problems 7, 8, and 9 in preparation for class tomorrow, and you will check answers when you walk into class, and we'll open the floor for any questions on these that you may have. When an object is subjected to gravity, we can determine its position, velocity, and acceleration based on the following formulas. And we were introduced these two formulas in Algebra 2. And again, this is for objects that are subjected to gravity, when you throw a ball in the air, hit a baseball, etc. Note that v naught, v sub 0, is the initial velocity, so v of 0, the velocity at time 0, that's v sub 0. And that a sub 0 is the initial acceleration, or a0. And s of 0 is the initial position. When an object is subjected to gravity, we are usually interested in how high the object reaches and how fast it's going when it impacts the ground or water. So let's look at what these concepts mean. When an object reaches its maximum height, what is its velocity? So if an object comes off, reaches its maximum height, what is that velocity there? Well, that velocity there is equal to 0. So to find the maximum height of an object, we're going to set the velocity equal to 0. We're going to solve for t, and that's basically we're finding the time when the velocity is 0. And once we find that time, once we know that the velocity is 0 at that time, we're going to go ahead and take that time and put it into the position function to find what the actual maximum height is. Okay, so once we find t, we can plug t into the position function to find what the actual maximum height is. How high does it really go? When an object hits the ground, what is its final position? When an object hits the ground, what is the final position? At that point, the position, which we call s, is equal to 0 because it has hit the ground. So, to find the velocity of an object when it hits the ground, how fast was it going when it hits the ground, set s of t equal to 0, solve for t, so we're going to find the time when the object has hit the ground, we'll find that time, and then we plug that time into the velocity to find how fast it was going when it impacted the ground or water. So v of t, once we find t, v of t is going to tell us how fast it was going when it hit the ground or water. Note that the weight of the object has no impact on these formulas. If a penny and a bowling ball are dropped from a plane, it takes the same amount of time for them to impact the ground. So let's take a look at these questions with some examples. A ball is launched vertically from ground level with an initial velocity of 112 feet per second. It is launched vertically, it is from ground level, and there is the initial velocity. So we're going to find the velocity and speed at t equals 3 and t equals 5 seconds. We're going to find how high the ball will rise, and we're going to find the speed of the ball when it hits the ground. So let's start with our position function, so our s of t. It is in feet, so we are going to use this position function. Our initial velocity is 112, and our initial position, it's ground level, so our initial position is 0. So now we have our position function, we have our velocity at negative 32 t plus 112, and we're going to go ahead and find the velocity, and we don't need to find the acceleration because they didn't ask us for it. We're finding how high the ball will rise and the speed of the ball when it hits the ground. We're also being asked to find the velocity and speed at t equals 3 and t equals 5. So we're going to go ahead and do v of 3 to find the velocity at t equals 3, and we're going to do v of 5 to find the velocity at t equals 5. And we'll obviously plug that in to the velocity function. So negative 32 times 3 plus 112, and negative 32 times 5 plus 112. And in both of those cases, according to the answers here, you've got 16 feet per second for this velocity, 16 feet per second. So the speed is also 16 feet per second. Velocity here we have negative 48 feet per second. And therefore, so the speed is the same, but for this one, the speed is 48 feet per second, because remember that speed is the absolute value of velocity. Now, how high will the ball rise? In order to find how high the ball will rise, what we'll want to do is find the time where the ball is at a maximum. Okay, so what time is this happening? Well, that is happening when the velocity is equal to 0, because at that point the particle, or in this case the ball, has stopped and it's going to change directions. All right, it was going up, now it's going to stop and change directions and go down. So we're going to set the velocity equal to 0 to find out what time is this happening at. So negative 32t plus 112 is equal to 0, which gives us a t value of 3.5. So at 3.5 seconds, the ball is up here at a maximum. So let's find out how high that is. What is the position at 3.5 seconds? Where is the ball at 3.5 seconds? So we're going to plug 3.5 into the position function to find how high the ball will rise. We found the time that the ball will be at its highest, but we actually want to find how high it is at that time. So when we plug 3.5 into the position function, we should get that height, which according to the answers is 196, but I want you to double check that. Now we want to find the speed of the ball when it hits the ground. So how fast is the ball going when it hits the ground? Okay, so what's the velocity when the ball hits the ground? So I need to know at what time, when is the ball hitting the ground? At what time is that happening? So what's happening here is my position is equal to 0 when it hits the ground. And I can solve that. I can take the position function and set it equal to 0 to find what time the ball is hitting the ground. When you set the position function equal to 0, this is a quadratic, so you're going to want to factor and set the factors equal to 0. You're going to get two answers. You're going to get at t equals 0 and you're going to get at t equals 7. Well, this makes sense because at t equals 0, that's when we started, and the ball is launched vertically from ground level. So at time equal to 0, my position was 0. Then it launched, and it took 7 seconds to get back to the ground. So this time equals 7 is when the ball hits the ground, after being launched. So at time equals 7, that's when the ball hit the ground. What was the speed at that time? Well, at that time, the speed is v of 7, the velocity evaluated at 7. So let's take the velocity, negative 32t plus 112. Let's evaluate it at 7 to find the speed when the ball hits the ground. And according to that answer, and we have to take the absolute value of it because it does say speed, which is the absolute value of velocity. According to the answers, that is 112 feet per second. So just double check those by using your calculators and let me know if you have any issues with that. Alright, so hopefully that was helpful. If you need to rewatch that, that's really it when we talk about objects subjected to gravity. So what I'd like you to do now on page 98 is try problems 7, 8, and 9 on your own. Be ready to check answers in class tomorrow, and we're going to have a work day on straight line motion. And to end this video, I'd like to show you two of my favorite things. One is Disney and the other is math. So ladies and gentlemen, here is your joke for today. One of my favorite characters, Mr. Buzz Lightyear, always says, "To infinity and beyond." Have a great day. See you tomorrow.